So we're starting unit 3, which is going to be our quadratics unit. So today we're going to look at converting between the two different forms of a quadratic. So your standard or general form is going to look like this. F of x equals ax squared plus bx plus c. That's the format it's in if you want to like factor it. It looks like a trinomial. So that's your standard or general form. All right, and then we have our vertex form, which is going to look like this. F of x equals, it still starts with A. This is going to look like the alphabet threw up on your paper here. It's like every letter possible. X minus h squared plus k. The reason that's called vertex form, or sometimes it's called transformational form, is because you can see what the transformations are and tell what your vertex is. This graph went right h and then up k. Do you see that? Like pretend those are numbers, like it went right 3 up 7, it's just the letters. So I'm going to draw a quick visual for you. This means that your center of your parabola, your vertex, would be the point h comma k. So you can find the center of your graph using that format. So like this one's better if you want to factor. This one's better if you want to graph. So it's good to be able to move in between them, all right, to find where that center is. So that's your vertex. And then we also have this line that I'm kind of dotting in the middle here that's called the axis of symmetry. If I could write. Axis of symmetry. Symmetric means it's the same on both sides, like you could fold it and it's the same on both sides. It is a vertical line. Do you remember if a vertical line is x equals something or y equals something? X equals, so it's going to be x equals whatever that h value is. Again, it looks weird right there because it's all letters. Once we do an actual problem and there's numbers, you know, like math, it'll make more sense when there's numbers in there. So these first 3, we're going to write the following in standard form, which means it's going to look like this. It's going to look like a trinomial. As a heads up, like disclaimer, these are easy, but they're tedious. So you just have to be willing to like do a little bit of tedious work, but they're not difficult. All right. So for this one, do you see how it says x plus 8 squared? That means you need to write the x plus 8 twice. The squared, I call it a twin. It means it's a twin. You have 2 of them. So it's x plus 8 times x plus 8 and then minus 3. Then you're going to distribute everything to each other. It really doesn't matter what order you write it right now. We're going to combine the like terms in the end. I call it FOIL though, first, outside, inside, last, if you've ever heard a teacher say that. It's just a way to stay organized. Here's your firsts, x times x. Close. X squared. Now I try to get you guys to do the outsides and insides together because it'll save you time. The outsides will be 8x. The insides will be 8x. So together, 16x, good. And then 8 times 8 is 64, and then minus 3. So your final answer, and I don't mind if you don't write an f of x in front of every single one of these. Again, I know it's tedious, but if you could slap an f of x in your final answer for your equation, this will be x squared plus 16x plus 61. So again, not hard. You just need to know your multiplication tables. Let's do another one. So that little 2, this one has a coefficient in it. That little 2 is going to just hold on and wait patiently. You're going to write the x minus 4 twice. Unless you get to a point where you are able to do that in your head, I'm okay with you doing that part in your head. But for right now, just write it twice because you're learning it. So squared means it's a twin. So that 2 is still going to hold on. Parentheses. X times x squared, perfect. The outsides give you minus 4x. The insides give you minus 4x. So all together, negative 8x, good. Negative 4 times negative 4 is plus 16. Cool. Now this one has one extra step that the other one didn't have. What are we going to have to do with the 2? It's distribute. All right, so I'm going to go ahead and put my f of x equals in here. We distribute the 2. That'll be 2x squared minus 16x. Now hold on, I'll try to get you to combine this so you don't have to do as much writing. It would be plus 32, but then minus 7. So 32 minus 7 is 25. Good. So I'm going to write up the first step while you guys are working so you can check it.
I think you're gonna do, you're ahead of us. And you're gonna add 1. Wait,
All right, that's what I got. Can you guys check that? 1 is an easy number to work with, but also harder. 1 plus 1 is 2, but 1 times 1 is 1. Are you guys good to this point?
Yeah.
Okay, minus 1x and minus 1x is minus 2x, but then negative 1 times negative 1 is positive 1. So weird there. All right, and then slap an f of x in your final answer so that it's still a function. I am getting, hold on one second, negative 3x squared plus 6x. Now this would be minus 3 plus 5, so plus 2. All right, question, go ahead. So I can hear him. All right, now what I want you to try with your group is factoring these. Now, as a heads up, it should, or you know what, here, we'll do the first one together, and then I'll let you try the other 2. You're going to draw your 2 sets of parentheses, and then how's it going to split?
X plus 4.
Good, and I usually say it's x and then 4 and 4. Now, they are both plus, so there is actually one more step. Does anyone know how you can rewrite that? Good. It is a twin. When it's a twin, you write it as squared. So what I want you to try with these is, draw your 2 sets of parentheses, but then you want to write it as something squared. And what you eventually want to do is get to the point where you can skip that middle step and just write it as something squared. So again, I'm going to pause and I want you to just take a minute and think about it, and then I'll write them up. All right, so what did you guys think for this one? It's going to be x and x. Good. Minus 6 and minus 6 will give you minus 12. Negative 6 times negative 6 is positive 36. So it'll be x minus 6 squared. Go ahead. No, you need that. 4 times 4 is 16. Negative 6 times negative 6 is 36. That's actually a really important number, and I'm about ready to tie it all together. Were you able to jump to the answer for this one? It would be x minus 5. Now, what I want you to notice is you have a 16, a 36, and a 25. What do you notice about all those numbers? They're perfect squares. And do you see how they're all positive? That's because when you square a number, it is always positive. Listen, what I want you to try with these 3 is come up with what that number would need to be in order for it to be a twin, in order for it to work out that way. So figure out what that number needs to be. It'll need to be a perfect square, and it'll need to be positive. And then I want you to write it as something squared. So give it a try. You're coming up with what that third number would need to be. It'll need to be a perfect square, and then write it as a twin, something squared. All right, so what did you think for this one?
29.
9. Good. And so in your little blank, it would be plus 3. Good. Let me tie it together. Look, 3 plus 3 is 6, and 3 times 3 is 9. Are you girls with me back there? Are you girls with me back there? I'm just making sure you're still good. All right, what do you think about this one? 49. And then in here, it would be x minus 7. Good. Negative 7 and negative 7 gives you negative 14. Negative 7 squared is 49. Now, this one was the tricky one. It is 1, and that's because 1 squared is 1. And then what goes in the blank? Mine's good. So this is called completing the square. That's what you just did. Congratulations, you figured it out without me having to say anything. Now we're going to actually slow it down and figure out how you got that. So how did you get from the 6 to the 9 and from the 14 to the 49? Like, how did you do that? Yeah, split it in half. So divide by 2, and then what? Square it. So it will always be positive because when you square a number, it is always positive. So we'll do a couple of these and then we'll do our halfway through break. Now, I always use a different color for this. If you want to, I mean, you've got like a million colors over there. You don't have to, but I just use a different colored marker. It doesn't show up real great on here, but you'll see what I mean. All right, now for this one, you're going to start by moving over whatever that third number is. Look at how I left a gap. You want to leave a little gap there. I subtracted the 8 to the other side. 8 is not the number we want, so we were kind of like, get out of here. Shoo, 8, go over there, we don't need you. That's like essentially what we did. We were like, move to the other side. Now is where you complete the square. And it's going to be this is what I do with a different color. It's not going to show up real great. Here, maybe I'll try green. If green will look a little bit. Does that show up? Sort of. What number is going to go there to complete the square? Yes. I need for everybody to focus together. You're going to take this middle number 4, you're going to divide it by 2 and square it. So weirdly, it's 4 because 4 divided by 2 is 2 and then 2 squared is 4. But look, if you added that to the left side, you have to add it to the right side. So that's what I do in a different color. If you don't want to, that's fine. We added 4 to both sides. Now the goal is you want to write it as something squared. That's the point. So what's going to go in the blank when we factor that? X plus 2. Nice. And then what's on the other side? You just have to kind of finish that up. -4. Good. And then that's your answer. So let's try this one. You're going to just copy down the first 2 terms, leave a little gap, like leave a blank there, and then you want to move that 1 to the other side. So what is it going to be over here? Yeah, -1. Perfect. And then I use a different color for this. You can or not, you know, whatever you want. But this is where you complete the square. What are you going to add? Good, 9. And then on the other side, +9. Whatever you do to the left side, you have to do to the right. And then the goal, this is like the whole point of it, is to be able to write it as something squared. So what's going to go in that little blank there? Good. X plus 3 equals 8. Or squared and then equals 8. Good. So this is going to be the same process, but there's going to end up being a fraction. Okay, so start out the same way. Copy down the first 2 terms, leave a little gap. You're going to subtract over the 3. The reason there's going to end up being a fraction is because 7 is an odd number, okay? But we're going to do the same process. You're going to divide by 2 and square. When you divide by 2, you end up with halves. Your fraction should be a halves, like something halves. What is 2 squared? 4. So when you square it, it should be fourths. Your fractions should be halves and fourths. Halves and fourths. If you get anything besides halves and fourths, you have done goofed, okay? If you don't know what to do, make up something that is halves and fourths. 2 and 4, with me? Okay, because fractions scare people, but it's really not that hard. So you're going to take 7, divide it by 2, and square it. Here's what I always tell everybody to do. Off to the side, little margin problem. Bless you. You're going to take 7, divide it by 2, and then show that you're squaring it. That's just a little mental note. I write in the margins of my paper all the time, little mental notes. Now, when you square a fraction, all you do is square the numerator and square the denominator. So here, I'll make this be my green part here. What is 7 squared? So 49, and 2 squared, 4. Fourths, all right? Now, if we added 49 fourths to that side, we have to add 49 fourths to this side. I know, I'm going to get everybody else there. Would you hold on?
I apologize. Forgive me.
So you're going to write it as blank squared, and what goes in there, you can look off to the side, our 7 halves, it is x plus 7 halves squared. All right, now when you go to do the other side, this is what Graham was saying here, you need a common denominator. Let me explain it. Common denominator, which would be fourths, Here's the $1 million question. How many fourths is a whole 3? 12. And it would be -12 in this case. And so here's your final answer. X plus 7/2 squared equals, and it's going to be something fourths. Do you see how we have halves and fourths? Halves, fourths. -12 plus 40, what is that, 37? Did I do that right in my head? Confirmation? Okay. If you were like, hey, I didn't quite get that, guess what? We're going to do another one. Go ahead and flip over. Remember, I'm recording this. So if you get left behind, I need to keep going so you guys can finish your classwork. If you get left behind in any way, you can always rewatch the video. All right, so for number 13, leave a little gap and you're going to subtract over the 2. Now, I realize that this 3 is negative, but it really doesn't matter. No matter what, you're going to add. It's always going to be positive because when you square something, it's always positive. So I usually just ignore that. All right, negatives complicate things. Off to the side, in the margin, a margin problem. You want to take the 3, divide it by 2, and square it. Just write that off to the side. I get people that write things off to the side and then try to erase it or scribble it out, like they're embarrassed of their work or something. That's your brain thinking thoughts, okay? You shouldn't be embarrassed of that stuff. So here's what we're going to add. I need y'all to focus back there, group in the back. All right, 3 squared. 9. Good. And then 2 squared. 4. So 9 fourths is what you're adding to both sides. You want to write it as blank squared. What's going to go in the blank? Starts with an X. Minus, and it's the number you wrote off to the side, 3/2. Now you need a common denominator. How many fourths is negative? What's 2, but -2? What's that? 8, good. 2 times 4 is 8, or 8 divided by 4 is 2, however your brain wants to do that. All right, so here's your final answer. X minus 3/2 squared. I get that you're talking about the math, but you're still talking over me. Everyone's got to be able to hear me. Equals, and then if you combine these, what's that going to give you?
1/4.
1/4. Halves and fourths. Now these last two have an extra number in front of them. You reach it?
Yeah.
So what you're going to need to do is factor out that number. But listen to me. I'm going to stand up because this is important. Only from the first 2 terms. You only factor it out of which 2? The first 2. Most of the time, it won't go into the third one anyway, and we don't care about that third number. You're going to move it to the other side anyway. So we're going to factor out as 3. It's GCF, but only from the first 2 terms. So that is going to leave you with just x squared plus 54 divided by 3. What is that going to be? 18x. Leave a gap. You guys, please stop it. And you're going to subtract over the 241. Now the problem is exactly like what we did before. You are going to divide by 2 and square. There won't be a fraction. 18 divided by 2. 9, good, squared. So you're going to add 81. Here's the only thing. You know, on all the other ones, I did plus on the left and then plus on the right. It's not actually an 81. It's a 3 times 81. So it is actually 243. And so here's your final answer. You're going to keep that 3 out front, write it as blank squared. What goes in the blank? X plus 9, good, equals, do you see why I made it a 241? I try to help you out with that, make it a close enough number. Negative 241 plus 243 is 2. That wasn't so bad. I kind of encroached on the space for number 15 though, so I'm gonna have to kind of start this down here. You're gonna divide out 2, factor out a 2, but only from the first 2. All right, so that would leave you with x squared minus 14x. Good. Leave a gap and it'll equal 1. Good. Then you divide by 2 and square. So 14 divided by 2, 7 squared. So put plus 49. But on the other side, it's not actually a 49. It is a 2 times 49. So 98. Good, thank you. And then your final answer, you leave the little 2 out front. It's blank squared. What's going to go in the blank? X minus 7, good, equals 99, weirdly. And now the whole point of doing this is so you can get a graph. That's the point. If I asked you to graph x squared plus 6x plus 8, can you tell what the transformations are? The up, down, left, right, or where the center is? No. So that's kind of the whole point of this, all right, is completing the square. So you're going to write the first 2 terms. I'll use a different color. You're going to be okay. Divide by 2 and square. So 6 divided by 2 is 3. Squared is 9. Now, usually what I do in this case, because there's not an equal sign, so you can't really slide it to the other side, I'll usually just give that whole thing a hug, meaning put parentheses around it. Just give it a hug. How do I turn this 9 back into an 8? What would I need to... minus 1. Do you guys see how 9 minus 1 is 8? Okay. And so your function, here's where I'm going to put the f of x equals back in there, is it's something squared minus 1. What would go in the blank? Follow your pattern. Good. X plus 3. So here's the whole point of that. Like, why on earth did we do that? Now you can see the transformations. Using words like up, down, left, right, how did it scoot around? How did it move? Left 3, down 1. Left 3, down 1. Boom, parabola. Do you see how easy peasy it is to graph when you can just shift it over? Versus graphing x squared plus 6x plus 8, you'd be sitting there making a table, plugging in 1, plugging in 2, plugging in 3, trying to figure it out. If you can just shift it, then it's easy. What's your vertex of this, the coordinate point that's that center? Yeah, good. And the axis of symmetry, you don't have to dot it in. I'm just doing this to show everybody. It's this vertical line that, cuts it in 2 symmetric pieces. It is x equals -3. It's not an asymptote. I don't want to confuse you. I just dot it so everyone can see it. We'll just do one more. So I think at that point, we'll have gotten it. Do you see how there's a negative in front of this one? You want to think of that as a -1. We're going to factor out a -1, but only from the first 2. If there's a number out front, only take it out of the first 2. That'll leave you with x squared and then what? Good, minus 8x. Leave a gap. I'm going to use a different color. We're going to divide by 2 and square. So 8 divided by 2, 4. Okay, I hear you guys saying the answer already. 16. Now hold on real quick. It's not actually a 16. It is a -1 times 16. So it's actually a... Okay. So if you have a -16, how do you turn it back into a -12? Good, you guys got it. I thought I was going to have to show you a visual. Do you see how you have to go right forward? Okay, so at the end, you're going to tack on a +4. And so your final equation, I'm going to put the f of x equals back in here. Negative or -1. I wrote the -1 so you could see that it's there. It's kind of up to you. Blank squared +4. And follow your pattern. What goes in the blank? It's -4. Good. So here's the whole point of that. Like, I'm big on like, what's the purpose? What's the goal? Like, why are we doing this? Now you can see how it transforms. So using words like up, down, left, right, how did this one move? Yep, so you're going to go right 4, up 4. and flip it. Good, thank you. So it's upside down. Weirdly, both the numbers were 4. So your vertex is 4, 4, and your axis of symmetry is x equals 4. I'll sit here and work out the last one, so it'll end up on the recording. You can watch that if you want to. Otherwise, I'm good with you starting your classwork.
You know, competition. I'm such a great. Look what I did. My friend, she needed silver plates for my phone, so I'm fine.